Dinosaurs is a subject which is exciting interest in all of us, perhaps because of the popularity of the film Jurassic Park. Dinosaurs existed on the surface of the earth at a very critical period of time. In India, perhaps we do not have as much information on dinosaurs as other parts of the world. However, in India, we have certain interesting features in the geological record which give us information about the extinction or the end of the dinosaurian age. In this regard, several studies have been carried out, and to know more about these studies, we have with us Professor S.K. Tandon from Delhi University. Professor Tandon is a member of the faculty of Delhi University. He served earlier at IIT and then in Delhi University. He is one of the leading earth scientists from this country and a winner of several medals, awards and recognitions, most prominent amongst them being the prestigious Shanti Swarup Bhatnagar Award in 1988, the Krishnan Medal of the Indian Geophysical Union earlier on, besides numerous which is too long to list over here. Welcome, Professor Tandon. To start off with, what is this age of dinosaurs that we keep on talking about or hearing about?
I think I would like to answer that by saying that it's always important to look at the entire time frame of the earth, and the age of the earth is takes us back to 4,500 million years, and life forms actually evolved from about 3,800 million years. Then there was a major diversification of life, and the major life forms appeared on the earth only about 600 million years ago. That is also in geological terminology, in the terminology of the geological time scale, referred to as the Cambrian. The base of the Cambrian is the time when there was an explosion of life. Now, when it comes to the dinosaurian record, the dinosaurian record is largely there in the Mesozoic era.
Okay.
And we divide the Mesozoic further into the Triassic, the Jurassic and the Cretaceous. And dinosaurs virtually ruled the surface of the earth. They were large forms and they existed for close on about 140 to 150 million years of time.
You mentioned Mesozoic. I mean, can you give us, like you mentioned, the age of the earth is 4,500 odd million years.
Yeah.
What is this Mesozoic era?
See, the Mesozoic starts at about 245 million years, and then it terminates at 65 million years. So that we have a duration of about 180 million years of time that is encompassed in the Mesozoic era. It is also an era which is substantially different from the succeeding era, which is known as the Cenozoic era. And we live, of course, now in recent times, and the Mesozoic was a relatively warmer earth. The earth was much warmer, and if we broadly tend to divide the earth into greenhouse type of earth and an ice house type of earth, then it is in the Mesozoic that we talk in terms of greenhouse conditions.
So, I mean, what special conditions in the sense of atmosphere or
it is important from the point of view of course, atmospheres, because atmospheric compositions have also varied in time, and the general climatic conditions varied very much. Conditions were far more arid and warmer than they were in the Cenozoic, and it is at the Mesozoic Cenozoic era boundary that the cooling trend of the earth starts. The earth was also free of ice sheets in the Mesozoic. So, the polar ice sheets were not there. Consequently, the interactions between the cryosphere, the oceans and the land, which is now a linkage between a three component system, the cryosphere, the land surface and the ocean, was different in the Mesozoic.
I see. So, basically this so to say warm and equitable Mesozoic favored the growth and expansion of dinosaurs.
while I suppose that might be one criteria, because what is going to happen is that the conditions, the geochemical, the large scale, the global geochemistry, the global geochemical conditions and the global geophysical scenario would actually promote different environmental conditions, and also therefore the entire biological response would be different. Dinosaurs were of course one life form. It's important also to think in terms of the plant communities, the changes that took place particularly towards the end of the Mesozoic in terms of major evolutionary changes in plants.
I see. So, I mean coming back to the dinosaurs, why do we not have any dinosaurs, to put it in a very simple way? What caused them to just stop being around?
I think there are some very important things that have happened in the terminal phase of the Mesozoic. And there are two things which as far as India is concerned, the Cretaceous is a time period which is which, as I said, finishes the era boundary and the period boundary are both at 65 million years, and the Cretaceous starts off at about 145 million years. So, you have a time span of about 80 million years. And in these 80 million years, we have got some very important geodynamic events taking place on the Indian crust actually. And we have got the addition of large volumes of volcanic materials.
I see.
Now, there are two major, as you can see in this diagram, there are two major volcanic provinces in India in the Cretaceous. And these are known as flood basalt provinces. One is in the east, which is referred to as the Rajmahal province, and is centered, has an age of about 115 million years. I do not know the duration right now, but on the other hand, if you look towards the western side, you see a large area of about 500 million square kilometers. And this area of 500 million square kilometers, which encompasses Gujarat, Madhya Pradesh, parts of Maharashtra, Karnataka and Andhra, has got the Deccan flows. These Deccan flows are very well known, and that actually the age is centered around 65 million years.
I see.
So, there is a renewed effort in the last decade or so towards finding out what is the duration of this volcanism. Earlier it was thought to be long ranging, and we had dates, potassium argon dates from 40 to 110 million years. Now, the new argon dating has shown that the duration of the volcanism is much shorter.
I see.
It might be as short as 1 million years, as some would propound, but generally it is accepted that it is within a time frame of 5 to 7 million years.
I see. To get back to the dinosaurs, I mean, has this any linkage with the vanishing of the dinosaurs?
I think volcanism is a very major process, and particularly accelerated volcanism, which influences the atmospheric conditions, which influences the earth's surface, it influences the water bodies on the earth, it changes the geochemical fluxes, and as a result of these things which happen, they tend to affect the biotic communities. Now, one of the things which happens at the era boundary, that is the Cretaceous Tertiary boundary, is the disappearance of several life forms. And when there is a major faunal turnover in a very short span of geological time, and here out of amusement I would like to tell you that short span of geological time is actually 4 million years.
I see.
So, a mass extinction is allowed 4 million years. But you have to look at this 4 million years in the context of 600 million years of Phanerozoic history. So, 4 million years when taken in the context of 600 million years is certainly a short duration. So, if we look at the Deccan volcanism as a short duration volcanic event of with about 5 to 7 million years of duration, then it more or less intersects the same time scale as is required for a mass extinction. Now, the dinosaurs, as we know, disappeared at the Cretaceous Tertiary boundary, and we have a record of dinosaurs in India. Can I have the next slide? You can see in this slide now what we see is the domain of the Deccan
Okay.
when it was not located where it is now,
Okay.
but it was located over the reunion hotspot
Mhm.
at 30 degrees south. So,
I
we
see.
know that there
Yeah,
is a
yeah.
latitudinal
Yeah.
shift also of the Deccan province.
Yeah,
And in the next slide we will see the present position of the Deccan. So,
Okay.
what we have of the Deccan today is only one part of what it was originally.
right.
So, the about 1,000,000 cubic kilometers of
Uh-huh.
volcanic materials that we have is now shown in this
Exposed.
diagram.
That's a large volume of volcanism, and that definitely would have a large impact on the overall ecological or environmental system. So, the concept being that this large volume of volcanism in some way changed the overall environmental system and caused the extinction, is that right?
That is true. You see, there are competing hypotheses here.
Uh-huh.
Now, in terms of the Cretaceous Tertiary boundary extinction, there is a strong school which believes that extinction is the result, or faunal turnovers are the result of a bolide impact,
I see.
that a large body, an extraterrestrial body with a diameter of about 10 kilometers impacted the earth.
Uh-huh.
And when such a large body impacts the earth, then there are major changes which take place. So,
Okay.
a lot of dust is being generated, and the dust can be global in character and it hangs, and consequently the fluxes between the earth and the sun are disturbed,
Mhm.
and that can again cause a lot of crises in the biotic communities.
I see. But I mean, a 10-kilometer wide, say, boloid or meteorite which hits the Earth's crust, tracing that is going to be a very major problem where it is. So, when we do not have any such direct record, what sort of evidences tell us that such a thing could have happened?
Now, the reason why such a hypothesis first originated was because in some sections, particularly in Italy and in Denmark, an iridium anomaly was found.
I see.
And that this iridium anomaly, we know that iridium is not a common element in the Earth's crust.
Yeah.
Right? So, if you find iridium which is generally absent at even ppb level parts per billion
Yeah.
concentrations, then you have to find an explanation for it.
Right.
But iridium is present in extraterrestrial materials,
see.
and it also is present at deeper levels within the earth.
Okay.
So, the mere presence of iridium is not sufficient to say whether this is belonging to an extraterrestrial source or whether it is belonging to an internal
Yeah.
source. However, the association of several features of shock, because when you impact, then there is a tremendous very high kilobaric pressures are there, and that causes the transformation of certain minerals, and for instance shock quartz.
Yeah.
And the presence of shock quartz associated with some of these layers, where evidence for extinction is also there, and iridium anomaly is there, tends to favor overall an external impact hypothesis more than an internal hypothesis. Nevertheless, the fact that there is accelerated volcanism independently also means that there would be very severe environmental and biotic crises taking place on the earth.
So, I mean, in context of particularly the extinction of the dinosaurs, one would find basically two schools of thought prevailing, one saying that it is the external impact as the root cause of all this extinction, and another school saying that no, perhaps it is the volcanism. In India, I mean, generally the opinion, if one were to look at from a common man's point of view, the opinion is that we do not have too many dinosaurs, and that is perhaps why they never became very popular till the Western scientists and Western world told us that there was an era of dinosaurs. Is that really correct?
I am not sure how correct that is. Can we have the next set of diagrams? What we see in this particular slide is the dinosaurian material is largely in associated sediments. When we talk about volcanism and when we talk about thick volcanic piles, thick volcanic piles are generally not erupting instantaneously in, and they are not
Sure.
one event actually.
Yeah.
So, there is a multiplicity of events.
Right.
And in terms of multiplicity of events, the stratal record actually shows individual flows. And there is also an interval sometimes, because all flows you do not have an interflow flow to flow contact.
Yeah.
There are places where you have flow, and then before the next flow comes there is a pause and there is sedimentation,
Yeah.
or there is soil formation.
Right.
When sedimentation and soil formation is taking place, many of these horizons
Yeah.
are actually fossiliferous.
Uh-huh.
Now, in the diagram that we have
Yeah.
shown in yellow color the
Yeah.
sediments which are more or less coeval with volcanic activity.
Right.
In some of these cases they are just beneath the flow.
Yeah.
Where they are beneath the flow, they are referred to as infratrapian sediments.
Okay.
And where they occur between two flows,
Okay.
they are referred to as intertrapian sediments.
Yes.
We probably have a look at the field situation. Can we have the next slides which show, which shows basically the distribution of the infra and intertrapian sediments in central India.
Okay.
Now, this central India is a good place to look at infra and intertrapian sediments, because the Narmada is a major river.
Yes.
And then we know that there is a depth to erosion over there. So, it actually erodes through the marginal country of the Deccan
Yes.
traps, and consequently the basal sediments
Yeah.
associated with the volcanics are exposed.
Right.
And these strata do bear a record of dinosaurs.
Yeah. This, if one were to look at this map, basically the idea that we get is some sort of a channel along which the present day Narmada river is present. Is it that the Narmada river has been flowing even at that time, or what is the available evidence?
No, I think it has got to do more with the fact that the Narmada has actually eroded its way to a deeper level here. So, Narmada being one of the major rivers,
Yeah.
and consequently it is a peephole
Yeah.
through erosion
Huh.
that we are seeing these outcrops.
I see.
As more and more erosion progresses, I am sure that there will be the distribution of the outcrops, because you see a very large area that is being
Sure.
covered by traps
Yeah.
now, and once the traps are removed, then there will be the underlying strata will be exhumed.
I see. That is very interesting. So, if I may summarize briefly what we have been discussing so far, what we now know is that the dinosaurs became extinct at the Cretaceous Tertiary boundary, and the various theories which try to explain the extinction of the dinosaurs, not only the dinosaurs, probably several other groups of organisms. In the next part of the program, we shall be discussing more about studies of this period of time in the Indian context. We shall try to understand from Professor Tandon what studies are going on and what they can tell us insofar as the Indian subcontinent is concerned. Thank you, Professor Tandon.